Hi! In this video, we will be using the definite integral and the method of slicing to calculate volumes and density. So here we go. So to start, before we get into volumes and density, we'll use the definite integral to calculate the area of this quarter of a circle. This is done easily enough by using just the formula of the area of a circle, just pi r squared, and dividing that by 4, because this is just a quarter of a circle. That's going to leave you with 5/2 pi for the area of this shape, but let's use the method of slicing so that we get comfortable with when we have to use it for more complicated situations. So, in this case, we'll be integrating with respect to y. Why? Because I feel like it. That's just the direction that I chose. You can also do this with respect to x, but in this example we're doing it with respect to y. Thus, an individual slice would look something like this. It's pretty neat. So, we're going to find the area of this individual slice. So we need to find this length here and multiply it by this height here, which is just going to be your delta y. So in order to find the length of this rectangle, we need to utilize this length y, because that will correspond to the point on the circle that has the right x value that we need. So what we do is rewrite the equation x squared plus y squared equals 10 in terms of y. X squared plus y squared equals 10. X squared equals 10 minus y squared. X equals the square root of 10 minus y squared. Now that we have this particular length right here in terms of y, we're just going to find the area of this individual slice. The length, x, times delta y. So we have the square root of 10 minus y squared times delta y. And the Riemann sum that represents the area of this entire quarter circle is the sum of all of the rectangles that you will make using this method at all of the heights y. So all you do is add a sigma, and as we let delta y go to 0 so that we have an infinite number of rectangles, we get a definite integral, which will be evaluated from the heights 0 to the square root of 10, because that's the highest that you're going to go with this function anyway. You wind up with the integral from 0 to square root of 10 of the square root of 10 minus y squared dy, and this is going to be equal to the area of this quarter circle when evaluated, which again is 5/2 pi.